Good morning, students. In today's class, we'll be comparing a methyl carbocation, methyl carbanion, and a methyl free radical. Starting with the methyl carbocation. Cation, since it is positively charged, the carbon in this case has got 3 bond pairs. In fact, carbon has got 4 electrons in the valence shell. In this case, it has got only 3 electrons in the valence shell, and all the 3 are used in the bond formation with 3 hydrogens. Thereby, you have got only 3 bond pairs. Since there are only 3 bond pairs, the hybridization has to be sp2. The bond angle would be 120 and the geometry will be trigonal planar. And this is how a methyl carbocation looks like. The 3 bonds on carbon in a plane with 3 hydrogens and a positive charge. The bond angle is 120 degrees. Plus you would also have a vacant p orbital of the carbon available for accepting the electrons, since it is a positively charged identity and it is running short by 2 electrons. The percentage S character in this compound is going to be 33.33%, since in sp2 S is 1/3 and 1/3 is always represented by 33.33% character. Moving ahead with the carbanion. A carbanion is a negatively charged identity where carbon, which has originally got 4 electrons in the outermost shell, will now have 1 more electron, that is 5 electrons in the outermost shell. Out of these 5 electrons, we will have 3 as bond pairs and 1 as lone pair. The 3 bond pairs and 1 lone pair makes the hybridization as sp3. The geometry has got 109.5 degrees as the angle, and it is a tetrahedral geometry. You have a carbon which has got a tetrahedral geometry where you have this kind of a structure with 3 hydrogens and 1 lone pair, and there is a negative charge on carbon. Lone pair not being visible, it appears to be not a tetrahedral but a distorted tetrahedral or a pyramidal geometry. Moving to the last category, a methyl free radical. In a methyl free radical, carbon has got 4 electrons in its valence shell, plus there is 1 electron more. Therefore, instead of 4, it has got 5 electrons in its valence shell, which is not correct. It has got the 4 electrons only. This 1 electron is its own electron that it has grabbed from the covalent bond. Hence, don't be confused with this single electron. This single electron is not taken away from any other atom, but it is its own electron. Hence, you have carbon with only 4 electrons, out of which 3 are used in bond pairs, and there is 1 unpaired electron. And this unpaired electron will also require an orbital to be placed in. Therefore, the number of orbitals you require again are 4. Hybridization again becomes sp3, but this time you would have 3 bond pairs and 1 single electron. The structure of a methyl free radical would be similar to a methyl carbanion. The only difference would be in the 4th orbital you will have a single electron along with 3 hydrogens. The geometry apparently would be trigonal pyramidal, but the angle would not be 109.5 because of the presence of lone pair or the unpaired electron in this case. The other case also, where I mentioned the geometry to be tetrahedral, which is actually distorted tetrahedral, therefore the angle also in this case would be less than 109.5 due to the repulsive interactions from the lone pair. This angle becomes less than 109.5. So the angle is lower. While in this case you have a single electron, not a lone pair, which will also cause unbonded electron and bond pair repulsion, causing the angle to decrease. This would be less than 109.5. But the geometry remains the same, that is distorted tetrahedral, or you may call it as pyramidal, and the angle is less than 109.5. If you want to compare the bond angles, the maximum bond angle would be for carbocation, which is 120. The next would be for a free radical because the repulsion is by a single electron, while the third and the least bond angle would be for carbanion due to the repulsion from the lone pair. So this becomes your order for the bond angles. Thank you.